All right, so we're back. All right, so I think the next thing I want to do is to get the animations put in here. So let's start with that. So there are a couple good animation packages in Elm. And this Elm style animation is a good one, but it only applies if you are animating CSS styles. So in our case, we're going to be using this mgold Elm animations, and along with it, we will probably also need this Elm community easing functions package. And I already have this package installed from a previous Codevember day. So we're just going to import it. And actually, before we start doing that, I think we should extract and refactor this code a bit. So I think we have two things we can pull out of this main file. One is this curve, which is just kind of a general shape. So let's move that out. Let's make a new file called shapes.elm. And because I'm in this folder structure, it's actually day13.shapes. And our type alias also can go in there. And then this file, instead of curve, we're going to use shapes.curve. And we will import day13.shapes as shapes. Oh, and I spelled 13 wrong. Okay, cool. So that's extracted. Then the other thing is these things for drawing the eye. So let's move that into an eye.elm. Whoops, I made it a folder. Oh shoot, I renamed the whole folder. This should be called day13. Okay, and I want a new file in here called i.elm. This is day13.i. And I think we only need to expose the top thing, which is going to be this. And I is just a collage.form. And it'll take all this stuff and put it in a group. And then we need to import collage, and we need to import color, and we need to import shapes. We need to import day13.shapes as shapes. And then this becomes simply i.i. I. And this is day13.i as I. Okay. Cool. So then color and shapes we don't need in here. And there we have it. Okay. So that's all extracted. Why don't I go ahead and commit this? So I'm going to go into my workspace, Codevember, and I kind of have a bunch of junk laying around from different days, so I'm just going to add day 13. Commit. So here we have basic I. Cool. So now we want to animate this. And to do that, we're going to have our eyelid animate up and down. So I want to have a float here, which is going to be how much the eye is closed. And we're going to pass that just to the eyelids. And let's see, so this is going to control the innermost flap of each eyelid, which is this one. And I think we just want to take this and multiply the closed by this. So if closed is 0, I guess we should flip this around. If we make it called open instead, then this will multiply nice and easy. So if they're fully opened at 1.0, then this will be at the same position as the top of the eyelid. And if it's 0, then the control point will be at 0, and it should be fully closed. I guess we'll see how this works out. So this will be called opened, and so will this. Okay, so we save that, and now our main should fail to compile, which it does, and we need to give it a parameter. So at 1.0 it's totally gone. At 0.9 it's like that. So I think we should maybe call this, we should modify this slightly so that 0.9 is actually the largest. So if we pass in 1.0, it'll actually pass 0.9 into the rendering. Okay, and if we're 0.5, they should be half closed. Okay, that looks good. Let's see, 0.2, and if it's 0, it should be completely closed. Great. Okay, so I'm going to leave this at 0.8 for now. And let's get this animated. So let's make our model type. And opened will be a float. Our initial model is going to be opened equals 1. Sure, let's use 0.8 for our default. And this becomes now our view function, which takes a model and is going to use the model.opened as the parameter. And view takes a model and gives back HTML message, which means we need to import HTML and our initial model is a model. Okay, cool. So now our program, which takes no flags, it's going to be HTML app dot, and I'm going to use a normal program. Whoops, and it looks like our dev server died for some reason. Well, okay, I'll look at that in a second once we have this compiling again. So we're going to have init, which is going to give back our initial model. Oh yeah, and the reason I was using the full HTML app.program is because we're going to be using well, we'll need subscriptions for time to do the animations, and we'll also be using commands for random generation later. So let's see, our subscriptions is going to be time.every. So every 100 milliseconds we will produce a tick. So let's start defining our message type, which means we're going to need to import time exposing time. And then we also need our update and view functions. So there's update. Let's define it here. It's going to take a message and a model and give back a model and a command. And we're going to have a case statement on our message. And if we get a tick, for now we're just going to return our same model. So we'll deal with that in a minute. And then our view function we have written. Okay, so now there's our eye again. Successfully compiling. All right, so now let's animate this opened property. So how does this work? We basically get a T, and we use that to call the animate function, and then we can use a particular animation. Let's see, and yeah, Mikey's got a question in the chat. When is Elm 0.18 supposed to be released? I don't know the exact date, but if you follow the Elm Dev mailing list, there have been a couple beta releases of it, and yeah, I would expect it before the end of the month, but I don't have any details about exactly when. Let's see. All right, so we need to define an animation for the eye. And I guess one question is, what's the best way to store this? I think we are just going to receive the new time here every time. And we'll use an animation. Let's see. So we need to specify the start time of the animation. Then we give a length and things like that. Okay. Okay. So I think we'll need a couple other things in our model. So we don't actually need to store the openedness because we can calculate that using the animation at any time. So what we're going to use here is we're going to say animation.animate. We'll pass it the current time. And I guess we can just store our animation in the model. Not sure that's the best thing to do. What are animations? Does this store functions inside of it? I think it does. So I don't feel that great about actually storing the animation in our model, but we can store the parameters for the animation in the model, I think. Let's see. I was going to look in here and look quickly at the animation type. Yes, so it stores the easing function inside of the animation. So for that reason, I don't actually want to put the animation into our model, but we do need to put the start time into the model. So we're going to have our I animation is going to equal animation.animation starting at the model.blink start, let's say. Then we'll have animation.from is the value, and this will be the eyelid animation. So we're going to start at 1.0, and we're going to animate to 0, and the duration of that is going to be pretty short, maybe 200 milliseconds. And delay, okay, we don't need any delay. Okay, so that's going to be our animation. And in here, we're going to animate it with the model.blink start, and then the eyelid animation. And we need to import the animation package. Alright, so what did we mess up? Our model. We haven't changed the model. So we'll have blink start, which is going to be a time. And I guess we'll start that at 0. And let's see. What else do we need? I guess the other thing we need is we want to get the current time that the app starts so we can have a blink start when we load the screen. Because right now, the time value of 0, that's like January 1st, 1970. So this eye blinked a long time ago, which is why we aren't seeing it blink now. So actually, let's do this. Let's actually use another subscription, and let's do a new time.every, and every 3 seconds we will start a new blink, and we'll add a start blink message to our message type. And let's see, what else? Oh, right. Sorry, we can't just return an array here. We need to say subscription.batch. Okay. So now we need to handle this new message type. So if we get one of these, we'll change our model and change the blink start time to the new time that we've received from this message. And, oh, I need an equal sign in there. There we go. All right. So, I was expecting us to see something animating at this point, so let's try debugging what's going on. So first let's check whether we're getting our messages. So let's put a debug.log here. And we're getting a tick. And yeah, every 3 seconds we're getting a start blink. Okay, so that's all working fine. Let's check this debug.log. And the blink start is, okay, so we have a value for blink start that's updating. Oh, right. Okay, so here's the problem. Our animation starts at blink start, but I'm sending the wrong time in when we apply the animation. So this actually should be the current time. And for us to have that, we need to start storing the current time in the model. So every time we get a tick, we will store that in the model, which means we're going to have now equals 0 to start with, and now is also a time value. Okay, so that's better. I'm going to increase the frame rate of our animation. And there's a problem with our blink. We never open the eyelid again. So let's take a look in this animation package and see what we need to create an animation that goes backwards as well. And I think for that, we're just going to use an easing function. Or can we combine two animations? Is running, is scheduled, is done. Change the two without an abrupt change. There's a delay, and there's a speed. Can we combine two animations somehow? Duration, animation, equals, life cycle, get start. Looks like no. But I know there is an easing function we can use. Whoops, here. And let's see, so we can reverse. If an object follows an easing function, and then the reverse, it retraces the same path. This starts fast and continues. Oh, this just reverses the time. And, here we go, retour. Transition that starts low, goes high. Okay, and then flips back. Yeah, so that's what we want, is the retour for our easing function. So how do we change the easing of our animation? We use animation.ease. And we pass it the easing function we want, which I'm not sure which one is the default here, actually. I think it might be the in-out sign. In any case, we can import that. We're going to use ease.inout. Let's just use in-out quad, and then we're going to retour it. So it'll go both directions. And we need to import the ease module. Oops, ease. So that didn't change anything. Oh, it kind of went both. It went in and out and then back in. Huh. Interesting. I guess I'm kind of confused now about how the animation package works, because I think it uses the to part to figure out which value, like it'll end up always being 0 after the end of the duration. So I guess we need to split this into different parts. I don't know. It seems like maybe this animation package isn't the best for doing what we want in this case. So basically what we want different is we want it to stay open at the end. Can we put just another 2 on here? I don't think it works that way. Yeah, that just keeps it open the whole time. I guess we could split this into 2 animations and call this one close animation. And then we have an open animation. So we'll get rid of the custom easing. And we'll start these at blink start. The open goes from 0 to 1. And this one is going to be delayed by the length of the first one. And then we'll just add these 2 together. Seems like kind of a silly way to do this, but I'm not seeing an easier way at the moment. Okay, well, in any case, it works. All right. So we have some animation working. Let's go ahead and commit this. And we don't need the easing module for the moment. So we added this parameter to our eye, and then we added our new animations. Okay, and I'll push that up in case anyone is trying to follow along right now. All right, so next thing I want to do is work on the texture for the iris. So again, here's our inspiration for that. And it looks like the way this works is there's kind of a ring, and then there's line segments that connect a subset of points on an inner ring to a point on the outer ring. And then those rings can rotate in different directions. So Sarai's here has 3 levels, which is created from connecting 4 rings together. I think maybe for ours we can just use 2 rings, and we'll have the pupil in the center, and then we'll have 2 rings compose the iris. All right, so let's try that out. So we have our iris. So this is going to change to a collage.group because we're going to have a bunch of stuff in there. So the first thing I guess we want to do is define, well, we're going to need the pupil radius in here. And then here, when we make the iris, we'll want to give that 50. Okay. And then we're going to need to make 2 rings. So let's make a mid radius, which will equal size minus pupil radius. Whoops, size minus. Oh, no, we want to add them and get 2. We want it halfway between them. So this should give us halfway. And then we want to draw lines between each one. So we'll need a way to generate the list of lines. So what's the best way to do that? Let's see. So I guess, okay, so we want to go around the circle, and I think for each point in this circle, we'll create all the lines that connect to it. So to do that, we'll need a function that can calculate a point on each circle given an index. And then we'll go through each point on the outside and connect it to multiple points on the inside. So let's see if we can draw the lines that connect to one of the points first. And to do that, we're going to have, let's see, we want a function that takes an integer, and then we'll use that, okay, so we'll have an outer point, which will take an integer and give back a point. So let's see, so for a point on a circle, the x is going to be cosine of the radius of the angle. So I guess we'll need to know how many points in circle. So let's make 20 for now. So that means this will be the degrees for this will be I times 20, or yeah, I times 360 divided by points in circle. And then times the outer radius, which for us is going to be the size, or is called size. And then the y position is going to be size times the sine of this same angle. Cool. And then we can actually just extract this to be called r. So this will be a circle point. We give it the radius and we give it an I, and it'll give us the point. So then what we want here is we want to make a line segment. And I think there's just one called segment. Let's check that. Yeah, which just takes the 2 points and gives a path. So we're going to have circle point on the outer ring of size, and let's use point 0 to circle point on the mid radius at 0, and then we're going to collage dot solid and draw that with color dot green for now. And what's wrong with my types? Oh, right, this takes 2 parameters, not a tuple. Now what's wrong? So expecting something that takes a path. Yeah, I thought solid took a path. Oh no, it gives us a line style. I see. So we need to collage.traced with that line style. Okay, and I'm not sure if you can see that very well, but I do see a line in here. Let's see, can we make a dark green? Is there such a color? Cool. So I'm not sure how well you can see that in the stream, but let's go ahead and add a couple more of these. And we'll draw from 0 on the outside to 1 on the inside. And we'll do a few of these. 2, 3. Okay, cool. So we're drawing a couple of those. So let's take this and I guess refactor it to use a loop. So we'll go from 0 to 3, and for each one, list.map make lines, I guess. I'm not sure of a better name for that for the moment. And we're going to pass 0 in for this, and then the second parameter will be this index used in the second line. So then this becomes make line, just make line. This takes two parameters, the outer eye and the inner eye. I guess I should call these index since I'm talking about this. So then the outer index goes here, and the inner index goes there. Okay, so we take all those, and we will put those in a collage.group. Okay, so next what we want to do is map over from 0 to points in circle. And for each of those, we're going to list.map make lines and put that in a collage.group. And then make lines is what we just defined. Make lines outer index equals this, and we will stick this in here. Okay, so at this point we might start hitting some performance issues. Interesting. Oh, right. So we're always going to the same 3 points, 0 through 3. So actually what we want to do here is go from outer index to outer index plus 3. Yeah, there we go. And if we increase the number of lines to or the number of circle segments to 40, cool. That's starting to look pretty good. And then what I want to do is let this take the two radiuses as parameters. So we'll change these to be parameters, and these will also be parameters here. And then we'll have a make ring, which will take these two parameters, and that'll do this. Then these parameters will get passed through to make lines, which will get passed through to make line. And now we can make ring with size and mid radius. And then we can also make a ring with mid radius and the pupil radius. Cool. So let's maybe increase the number here that we do. Let's make it 5. And let's see. The other thing we want is, I guess, the offset. We're going to want to rotate each of the rings. So we're going to need an offset that we can pass into each of these. And that is something we'll want to animate. So let's see. I'm trying to think through the best way to put this in. I guess we could just start adding it. So basically when we make a circle point, we'll have an offset. Which I guess we'll just add to I. Yeah, so I guess we don't even need it in there. We can just add it in here when we call this. So this will be plus outer offset. And that's going to be a float. And we'll also have an inner offset while we're here. Let's just add it. Then here we're going to also pass in the outer offset and the inner offset. Then when we pass this, we'll also pass both of those. And when we call make lines, the outer index needs to be the last parameter for the currying. So then we'll add both of these here, and we'll add those there. Okay. And in these cases, we're going to have 3 things. So in this case, it's the outermost offset, followed by the mid offset. And in this case, the outer one is the mid offset, and this one is the pupil offset. Okay, so we're going to need 3 of these additional parameters here. And those will all be floats between 0 and 1. And let's see, I spelled it wrong here. Okay, so now where is our compile error? Alright, so we need to pass it in now. And let's see. Let's just pass in a single float for right now. I'll just call it a rotation time. And then we'll calculate something based off of that. so the iris is going to have outer offset, middle offset, and pupil offset, so all three things. And this I'm just going to calculate using sine and cosine right now. So this will be sine of rotation t. And this one will be sine of rotation t times 3. And this will be sine of rotation t times 1.7. Okay, so now we need to fix up our main. And we'll pass in just some float. So let's just pass in model.now for that. Actually, that'll probably be too fast. Yeah, let's pass in model.now over 1,000. Yeah, there we go. All right. So I think it's about time for another short break here. So when we come back, we'll probably do a little bit of cleanup on this code. But then I also want to set up some different parameters to randomly generate some different eyes. And actually, we might end up putting multiple eyes up on the screen as well. And actually, we probably want to fill in the, I'm not sure what the white part of the eye is called. I guess the white of the eye. Because right now we're just relying on the background color. So maybe we can set a background color for the canvas as well, and make sure that we're filling in the white part. And we can potentially draw that in different colors too. So we'll take a short break. We'll be back in just a minute or two.